Hey everyone, look at number 6 in section 1.6. We're going to solve for x in this exponential equation. Okay, in this section there were some log equations, and now this is an exponential equation. When we're solving exponential equations, essentially what we want to do is isolate the exponential expression, which is that, isolate that by itself, and then we'll use logarithms. In this case, since the base is e, we can just take the natural log to find the solution. We do want to give exact answers, and that means we're going to use symbolic notation. So if we can't evaluate a logarithm, then your answer will have logarithms in it. In this case, we'll have the natural log, which is log base e, usually abbreviated just ln, correct? That's the way we normally do that. So how do I isolate this expression? I need to get rid of the 6. Remember, I'm multiplying by 6. So how do I undo multiplication? By dividing. Okay, please do not subtract 6 from both sides. You can't subtract 6 from 6 times e to the negative 7x and get anything. Okay, we have to divide by 6. 6 divided by 6 is 1. I just have e to the negative 7x. 2 divided by 6 is just 1/3, right? And now I'm going to take the natural log of both sides. And so that's the way we solve. And so the natural log of e to the negative 7x, right? That's the inverse relationship. If I take the natural log of e to the a, I get a. Why is that? Remember, the logarithm is the exponent, right? On the base, needed to get e to the a, right? So e to some power is e to the a, right? So e to some power is e to the a. Well, that's the easiest problem in all the world, right? The answer is a. So the natural log, the exponent on e to the a of e to the a is a. Okay. Or we can also say e to the natural log of a is a, because what's the natural log of a? That's the power of e needed to get a. So if I take e and raise it to that power, I get a. Right? These are the inverse relationships that we have, okay, between exponential and log. So when I take the natural log of this, I get negative 7x. Okay. And then to solve for x, I can divide by negative 7, right? Which would be the same thing as multiplying by negative 1/7. Okay. Since I've got it in this form, it's a little bit easier to write it that way. Now, this is the correct answer, but it can be written a little more compactly. And so how can we do that? The log of 1/3 can be written a little bit differently by using the properties of logarithms. You should be familiar with these properties of logarithms. We use them in pre-calculus to expand and condense logarithmic expressions, if you remember, and we use some of these properties in solving logarithmic equations. In calculus, we use these properties quite a bit. We'll use them in something called logarithmic differentiation in particular, and sometimes we need them in solving log equations. So you should be familiar with them. The natural log of a times b is the natural log of a plus the natural log of b. Again, this should make sense when you think of logarithms or exponents. What do you do with the exponents when you multiply like bases to different powers? You add the powers, right? The natural log of a divided by b is the difference of the logarithms. Why is that? Again, if you're dividing like bases to different powers, you subtract the exponents in the correct order. Notice it's the natural log of a, the top, minus the natural log of b. And then the natural log of a to the n is n times the natural log of a. Again, why is that? Because when we take an expression and raise it to another power, then we're going to multiply the exponents. And again, the natural log of a is the exponent on this expression. Okay. With that, notice I can use the second property here to write the natural log of 1/3 as the natural log a is 1, natural log of 1 minus natural log of 3. And the natural log of 1, now that's nice because natural log of 1 is 0, since why? E to the 0 is 1, right? And what's the exponent on e needed to get 1? Answer is 0. And so back to log base a, if I take any base, base e, base 2, base 10, whatever, that's always 0, right? That's a fact that we need to know. And so if anytime we see a 1 floating around and we're taking the natural log or a log of it, we're going to want to simplify that obviously to 0. So the natural log of 1/3 is 0 minus the natural log of 3, or negative natural log of 3. So I'm going to replace the natural log of 1/3 with negative the natural log of 3. And notice this works out good because a negative times a negative is a positive. So I have 1/7 times the natural log of 3. And finally, I can just rewrite that as the natural log of 3 divided by 7, right? Multiplying by 1/7 is the same as dividing by 7. This would be the most favorable form for it. I say this because Achieve sometimes will give you a little trouble. It wants it in a particular form. The directions were to use symbolic notation, so that's where the log comes in, and fractions were needed. And so it's looking for maybe a form like this. On a test or something, if you got to this point, I would be pretty happy with that and give you full credit. For instance, if if this was a pre-calculus class, I'd be really happy if you got to that stage. But again, if you're having any trouble with solving equations, logarithmic equations, exponential equations like we did here, or trig equations or anything else, please let me know.